Right, let's solve some questions. Now, a plane progressive wave is represented by the equation. You're going to come here, you write y equal 2 sine 100 pi t. Sorry, that's 2000 pi t minus 0.5x. The first thing you want to do is to write your equation, the general equation of wave motion, which is y equal a sine 2 pi ft minus 2 pi x over the lambda. Now, there's something I want to take note. Whatever is given to you must look like this. Because we'll be using the comparing formula. We'll be comparing both formula, both equation, this and this. Whatever is given to you in the equation must look like your wave motion formula. Because in the point where I was generating the formula, I didn't give us various way in which the formula can appear. But when I'm solving this question, I'm going to do that. So right now, this looks like this. Y and Y, equal and equal, A and S, sine and sine, this and this and this. Okay. Another thing I failed to do was to tell you what each and every one of these is. So then just go straight into doing that. Y is the displacement and the vertical origin. A is the amplitude. And then we have L as the frequency, we have T as the time, we have lambda as the wavelength, and then we have X as the position. And please note that everything here, this 2 pi x over lambda is called the phase angle. Please take note of that. Alright. So, sorry, let me clean this. I need that. Okay? So, let's dive into the question. We asked to find the frequency. The frequency. Now, you're going to come here and ask yourself, where is the frequency? And you can see the frequency here. And what is here is time, x, right? I will come to this my equation and look for this alphabet, which is t, the time. This is the time. What I will now do is, I will equate everything here. And that's because t and t, x and x, this is for x, this is for time. So I'm going to write 2000 pi t equal to 2 pi ft. T will take t away. Pi will take pi away. 2 in itself 1, 2 in this is 1000. So it means my frequency is 1000 Hz. It's very simple. Look at this. What is the wavelength? I will come to my equation and look for wavelength. This is wavelength. Wavelength is associated with x here. I will look for where x is. X is here. So I'm going to equate this together. So it now be 0.5x equal to 2 pi x over lambda. X cancel x. Right? I'm looking for my wavelength. The wavelength now is equal to 2 pi over 0.5. We're told that pi is 3.14. So I'm going to check my calculator, and then the value is 12.56. 12.56 centimeter. Why is it centimeter? Because we're told that is in centimeter. Alright, but we're told that y and x are in centimeter. Okay, so let's proceed. We have to find the period. We already know that period is 1 over frequency, which is 1 over 1000, which is 10 to the power minus 3 seconds. That's all. To find the speed, we know v is equal to f lambda, right? So it will be v equal f is 1000 times 12.56. V is equal to 12,560 centimeter per second. So in meter per second, I will divide by 100. 1, 2. So V equal 12.560 meter per second. So this is the speed. I'll go to the next one. Angular speed. What is angular speed? Angular speed is W. Is taken, and that is 2 pi m. 2 pi m. So I write W equal 2 pi times F is 1000, and that should give me 6283.2. What's the unit? Rad per second. Okay, and the last one is the amplitude. Look at it. Y to Y equal to equal, amplitude to 2. So it means that my amplitude is 2 centimeter. And that's very simple. Very simple. Okay, let's go to question 2. A way has an amplitude equation of, amplitude equal 4.0. So I'm going to write my amplitude equal 4.0 meter. Let's continue. Angular speed, which is W equal 1/3 pi rad per second. And phase angle, what is phase angle? 2 pi x over lambda. Please take note of that. Equal to 2 pi over 3 rad. Now, you see the displacement y of the wave is given as. Now, let's write what we know. Let's just write what we know. Y equal A sine 2 pi ft minus 2 pi x over lambda. This is what we know, right? If this is what we know, how do we now put in this value? We have A is perfect. We have phase angle is perfect. But the problem is we don't have the angular speed yet. So how do we solve this? That's why I told you, we know this is a general formula, but it can be represented in various forms. So if we want to represent this in various forms, we already know that W is equal to 2 pi f, right? So I can write this equation as y equal A sine Wt minus 2 pi x over lambda. So it means that my equation of wave motion can be this. It can be this. We're going to see different ways. So I will write y equal A is what? 4.0 sine W is what? 1/3 that's omega pi, right? C minus the phase angle, everything here is 2 pi over 3. So this is the answer. I can simplify this further. I can write it as y equal 4.0 sine. We have the common denominator, so I can just write 1/3 and put my pi here and put it as t minus 2. The same thing, I just simplify it. What is common between this and this? I can see 1/3, I can see common denominator 3, I brought it out. I can see pi and pi, I brought it out. So what is left is t minus 2. Do you understand? Right, let's go to question 3. A traveling wave moving from left to right. Moving from left to right. So now the equation we'll be using, moving from left to right, will be A sine 2 pi x over lambda minus 2 pi f t. Please take note, it's moving from left to right, be starting with the face angle minus this. Then just swap it. Okay. Let's continue. As an amplitude, alright, A equal 0.15 meter, alright, and a frequency which is 550 Hz. Okay, and a wavelength lambda which is equal to 0.1 meter. The equation describing this wave is, now that is an objective question, and the reason why I brought that is because if I use what we know, this is what we know. If I use what we know to solve this question, you discover that what I'll be having here will not look like this. Are you with me? It's not look like this. So what do you notice? This is what I notice. I can see that pi is out. In all the options, I am trying to solve the question looking at the options. I can see that pi is out. I can see that x is alone. I can see that time is alone. It means that pi has been factorized out. That's one. This pi has been factorized out. One. These two has been factorized out. Because if the 2 was there, it would be with this x. Are you feeling me? Alright, another thing I can see is that I can see over wavelength. I can't see over wavelength. It has been brought out. So it means, let's constant. 2 is out. It's a constant. It's not even necessary. Let's start. Wavelength and lambda pi is out. I want to say constant. So 2 pi is out. And I can see that this wavelength is out of all these options. So it means I have to take away 2 pi and I have to take away wavelength. So this is how we take it away. Let us cancel it. So this 2 pi x over lambda minus 2 pi ft. You have so many ways. This is pure math, like factorizing variables out. We have so many ways of doing it. Let me take this root. I'll take 2 roots. So this is y equal a sine. We want to bring out 2 pi over lambda, right? So we have x. Can you see that x is standing in the root? Minus 2 pi ft lambda. Because if you are taking out a denominator that is not included in this variable, all you just need to do is what? Multiply by lambda. Why? 2 pi over lambda times x will give us this, right? Let us try this. 2, what am I doing? What am I doing? I'm taking out 2 pi. So what I should be left with is ft lambda. Sorry for that. I'm taking 2 pi over lambda half. Alright, so I'm saying if I'm taking this lambda half, can you see lambda here? No! So I will just have to put lambda up here. Why? Because it will be 2 pi times everything here times this. Look at it. 2 pi over lambda times ft lambda. This will cancel this. I will let it 2 pi ft. Can you see? Can you see? Right. Some people are still looking and looking confused. What if I say a? If I say factorize a out of ap plus b, what would the answer be? Going to factorize a, it will be a p plus b over a. So if it is a that is this, if what I'm factorizing out is a, not a denominator, I will introduce that value as a denominator in the variable where it is not found. Why? Because when you factorize out and want to expand back, you must have the same answer. Look at it. A times b is ap plus a times b over a. A will come to a, or will let to b. Do you understand? Okay. Let me do another one. Whatever I have, say I want to factorize a out. 1 over a out. Alright? 1 A, P plus what? A, B. So this denominator is just like taking the inverse. So 1 over A times P, it will be P over A plus 1 over A times this, 1 over A times AB. A cancel this. I will let with B. Like, this is just straightforward. Very, very straightforward. But this has returned back to this. Okay, so having said that and justify myself on that, okay, so this is y equal A sine 2 pi over lambda x minus, is there any need for that? No, there's no need for that. So everything is settled now. Everything is settled now because this is looking like what is in my option. Very simple. Another way of doing it is saying y equal A sine, okay, let me put this 2 pi x over lambda. The question now is, we're not having lambda, how do we now factorize if you don't know this principle? We know that V is equal F lambda, right? We know this. V equals F lambda. Wait, sorry. Okay, let's continue. So, and in this my head, I can substitute it as over lambda cancel lambda, F equal V over lambda. So easy of writing it now, alright? 2 pi V over lambda T. Give this up. Now I cannot factorize 2 pi over lambda. Can you see 2 pi over lambda here too? So it now becomes y equal A sine 2 pi over lambda. What will be left is x minus dt. Now back to this. You know that f is this, right? So it's now be y equal A sine 2 pi over lambda equal x minus f has become b over lambda c lambda cancel lambda. So we have y equal A sine 2 pi over lambda x minus bt. I don't know which one you prefer. But anyone you prefer, we give us the same answer. Alright, so wavelengths, we have wavelengths. Do we have, so it means, it means that the equation of motion can be written like this. I will show you another way. So we have A, amplitude, we have frequency, and then we have lambda. Now you look at this equation very well. Which one is best? Is it this or this? Now we don't have speed. Some of you might memorize this. You might keep this in your brain. Me, I prefer keeping this. Alright? Some people can decide to choose this. And we are seeing that there is no speed here. You can relate it back to having your frequency. So the best formula to use is this. So it means these two can be written as equation of, the mathematical representation of wave motion. These two is approved. So all you just need to do is play with them wisely, So I'm going to write y equal, my A is 0.15 sine 2 pi over my wavelength is 0.01, and then I'm going to write x minus my f frequency is 550 times t times 0.01. So what I'm going to have is 0.15 sine 2 divided by 0.01 is 200 pi x minus this times this 1, 2, 1, 2. So it will be 5.5 t. The correct answer is this. Please, all you just need to do is choose the one you prefer. You might prefer this, you might prefer this one. You might prefer this one, which is my choice. From here, I can arrive back here. Do you understand? From here, I can arrive to this point. From here, I can arrive to this point. So it's just the one you prefer. Do you understand? Let's go to question 4 and see what I'm talking about. Alright, so to question 4. Now, question 4, I want you to see this. The equation given to us is, let's find the following. We're going to use this. It's fine everything. Alright, so let's go. Y equal 2 sine pi 0.5x minus 200t. Alright, so I'm going to write my equation. The one I prefer, sine, I'm seeing x here, so I'm going to start with the face angle. 2 pi x over lambda minus 2 pi x. This is my choice. Might not be your choice. But if I look at what is given to us, I'm going to discover that pi is outside. Just pi. So I can't start saying y to y, a to 2, sine to sine. No, it's not correct. So the first thing I need to do is make sure that my wave motion equation looks like this. And how will it look like this? Pi is already factorized out. So I have to bring out this my pi, these two guys, to bring them out. So y equal a sine pi, what we left is 2x over lambda minus 2ft. So in other words, I will not be using this again. I have derived the formula I want to use because I can see y and y, equal and equal, a and 2, sine and sine, pi and pi. Now I can start solving. Do you understand? Now, the first thing is where I have to find is the frequency. I will come here, I will look for frequency. Frequency is here. So frequencies you can see, so I'm going to equate these two guys together. So it will be 200t equal 2ft. T cancels T, 2 in this 1, 2 in this 100. So my frequency is 100 Hertz. Oh, so simple. They're asking us, what is the wavelength? I will come and look for wavelength. Oh, that's wavelength. Wavelength is with X. So I'm going to associate this together. Do you see why it's very, very important that it must look like this? If you use the initial one, you might miss the answer. So I will have 0.5 x equal 2x over lambda. X cancels x. Lambda is equal to 2 divided by 0.5. And a half of 2 is 4. Like 2 divided by half, sorry. It's 4. Or what? 4 meters. Okay? Let's continue. What's the period? We already know that period is 1 over frequency. So it's 1 over 100, which is essentially as 10 to the power minus 2 seconds. Now we have to find the speed. V is equal to F lambda. F is 100 times 4. So V equal 400 meters per second. Now sometimes they can give you the speed. I think I've explained everything already. Okay? So angular speed as W equals 2 pi f, right? 2 pi f, which is 2 pi times f is 100. So my answer is 200 pi rad per second. You can decide to put the value for pi. I think we know it like this. Okay, so now the last thing is the amplitude. Look at it. 8 to 2. So it means the amplitude is equal to 2 meters. They can give you one kind of value, they can give you 0.2 times 10 raised to the power minus 8, so whatever. Whatever is before sign is actually the amplitude. Alright, so we've come to the end of the calculation of everything that has to do with the mathematical representation of waveform. We've done the progressive wave. If you've not watched it, go and watch it. And then we've done the stationary wave. If you've not watched it, please go and watch it. And this is the last thing we're doing wave before we move to other aspects of wave, like light wave, sound wave, and so on and so forth. Please do like, please subscribe. Subscription is free. And share with your friends that do not understand wave. If you have a problem with, I believe they can watch this. You should have a comprehensive understanding of wave. And lastly, please comment. Thank you very much, and God bless you.